Hello students, today we will discuss about solution of exercise 7.4. Today we will discuss about the remaining question of this exercise. In the previous video I have discussed about question number 1 to 5 of this exercise. Today we will discuss about question number 6, 7 and 8. So let us start with question number 6. Here is question number 6. The vertices of triangle ABC are A 4, 6, B 1, 5, C 7, 2. A line is drawn to intersect the sides AB and AC at D and E respectively, such that AD by AB is equal to AE by AC is equal to 1 by 4. You have to calculate the area of ADE and compare it with the area of ABC. You can recall the theorem 6.2 and 6.6. This theorem 6.2 is actually BPT theorem, okay, basic proportional theorem, and this 6.6 theorem is the theorem from the chapter triangle. It is related to ratio of triangle and ratio of the corresponding sides for two similar triangles. Okay, now what is given in this ABC triangle? The coordinate of A, B, C are given. Here D and E are the points on AB and AC side respectively, such that AD by AB is equal to AE by AC is equal to 1 by 4. You have to find the area of this ADE triangle and you have to compare it with the area of ABC. Now since the vertices of ABC are given, so you can easily find what will be the area of ABC triangle, right? Now for ADE triangle, if you want to compute the area of ADE triangle, you have to find what will be coordinate of D and what will be coordinate of E. So let's check the solution. Okay, look at here. AD by AB is equal to AE by AC is equal to 1 by 4 given. So I am considering this AD part as X. Okay, if AD part is X, since AD by AB is equal to 1 by 4, that means if I consider AD as X, that means X by AB is equal to 1 by 4, or you can say that by cross multiplication AB is equal to 4x. Okay, that's why AB is equal to 4x. Okay, so since this one is x and the whole is 4x, that means this BD part will be 3x. 4x minus x, that is 3x, so the BD part is 3x. Now if you find the ratio of AD and DB, it will be x by 3x, that is 1 by 3. Okay, so you got AD by BD is equal to 1 by 3. Similarly, you can say that AE by EC is also 1 by 3. That means this D point will divide this AB line in 3 is to 1 ratio. This is 3 is to 1. Similarly, this E point will divide this AC line in 1 is to 3 ratio. Okay, this part is 1 and this part is 3. Okay, now in AB side, the coordinate of A point and B point are given, and also the ratio is given is, if you consider AB line and D point, it will be 1 is to 3. Similarly, E point will divide this AC line in 1 is to 3. So the coordinate of D point will be by section formula 13 by 4, 23 by 4. Similarly, the coordinate of E point will be 19 by 4, 20 by 4. Now you got the coordinate of D and E point. Now use this ADE coordinate for evaluating the area of triangle ADE. So the area of triangle ADE will be 15 by 32 square unit. Okay. Now also the coordinate of ABC triangle are given. Okay. So again put the coordinate of ABC triangle in this formula. You can say that area of triangle ABC will be 15 by 2 square unit. Okay. Now you got the area of ADE triangle. Now the last part was you have to find the ratio of area of ADE and ABC. If you find the ratio, it will be 15 by 32 by 15 by 2, which is 1 by 16. That means the ratio of ADE and ABC is 1:16. Okay. Now if you recall this theorem 6.6, that's your theorem 6.6 was, if two triangles is similar to each other, then their ratio of area is equal to the square of ratio of corresponding sides. Now if you look at this picture, okay, if you look at this picture, as you can see, AD by BD is equal to AE by EC is equal to 1 by 3. So you can use BPT theorem. Since this ratio is equal, so you can say that this is parallel to this one by BPT theorem. Now since they are parallel, so you can say that this angle will be equal to this angle by corresponding angle. This angle will be equal with this angle. That means by AA similarity, you can say that triangle ADE will be similar with triangle ABC. Okay, and for both ABD and ABC, A angle is common, so they are similar. Now since they are similar, so you can say that area of ADE by area of ABC is equal to the square of the ratio of corresponding sides, that is AD by AB whole square. Okay, AD by AB is given as 1 by 4, that is 1 by 4 whole square, which will become 1 by 16. As you can see, this answer and this ratio are same. So that is the part given in the brackets, that you have to verify the answer by BPT theorem and theorem 6.6 also, and you can see that for both the cases the ratio will be 1:16. Now question number 7. Let A, B, C are the vertices of triangle ABC. The median from A meets BC at D point. Find the coordinate of D point. Okay, so first of all, this is the picture. As you can see, this AD is the median on the side BC. You know that D will be, since it is median, D will be midpoint of BC. So by midpoint section formula, you can find what will be the coordinate of D. The coordinate of D will be 6 plus 1 by 2, 5 plus 4 by 2, that is 7 by 2, 9 by 2. Okay, so first part is done. Now second part, find the coordinate of the point P on AD such that AP is to PD is equal to 2:1. Okay, so this is the P point. This is the P point. This P is dividing this AD in 2:1 ratio. So what will be the coordinate of P? Obviously the coordinate of A is given as 4, 2. You have evaluated the coordinate of D as 7 by 2, 9 by 2. Okay, and this is the ratio as 2:1. So by section formula you can find what will be the coordinate of P. The coordinate of P will be 11 by 3, 11 by 3. So this is the second part. Now third part, find the coordinate of the point Q and R of the median BE and CF respectively such that BQ is to QE is equal to 2:1 and CR is to RF is equal to 2:1. So suppose I am drawing a median. Okay, suppose I am drawing a median on the side AC. Okay, suppose this is E point. Okay, and this point, suppose they are not passing through. I am telling you, suppose this point is not passing this point, there is a point Q on this BE line, BE median, which divides this BE line in 2:1 ratio. Now you have to find what will be the coordinate of Q point. Okay, now again this BE is a median, so you can find what will be the coordinate of E by midpoint section theorem. Okay, so by midpoint section formula, the coordinate of E will be 5/2, 3. Okay, now you got the E point. The coordinate of B is also given. E is becoming 5/2, 3, and this Q point divides this BE line in 2:1 ratio. So again by section formula you can find what will be the coordinate of E. Okay, so what will be the coordinate of Q? So the coordinate of Q will be 11/3, 11/3. Okay, similarly suppose I am drawing this CF line. Okay, and suppose there is another point R on this CF line, and this R dividing the CF line in 2:1 ratio, then what will be the coordinate of R? Okay, first of all I have to find the coordinate of F. Again F is the midpoint of AB, so from midpoint section theorem I am evaluating the coordinate of F, that is 5, 7/2. By the similar manner, since this coordinate is 5, 7/2 and R dividing this CF line in 2:1 ratio, so by section formula the coordinate of R will be 11/3, 11/3. Now if you look at the coordinate of PQR, the coordinate of P was 11/3, 11/3. The coordinate of Q is also 11/3, 11/3. The coordinate of R is also 11/3, 11/3. That means the coordinate of PQR is same, and you know that for each point the coordinate have to be unique. That means these three points are actually same. Okay, that means P, Q, R, these 3 points coincide to each other. That means these 3 medians AD, BE and CF will passes through a single point, and that single point is this P point, which is known as centroid. Okay, this is the centroid of the triangle. As you can see, the 3 points are equal, so they will coincide to each other, and that single point is P, which is also the centroid of a triangle. Okay, this is the observation. If you check the question here in the part number 4, it is given that what do you observe? Okay, this is, you have observed that this P point will be the centroid of the triangle, which divides the median in 2:1 ratio. Okay, now question number 8. ABCD is a rectangle formed by the point A, B, C and D. The coordinates are given. P, Q, R, S are the midpoint of AB, BC, CD, DA respectively. If the quadrilateral is the quadrilateral PQRS a square, a rectangle or a rhombus? Justify your answer. Okay, so this ABCD is a rectangle given. Okay, and the coordinate of this A, B, C, D are also given. Since P is the midpoint of AB, so by midpoint section formula you can find the coordinate of P, which will be -1, 3/2. By the similar manner, you can find the coordinate of Q, which is 2, 4. In the similar manner, you can find the coordinate of R and the coordinate of S, which are 5, 3/2 and 2, -1. Okay, so let's check the solution. here since P is the midpoint, so by midpoint section formula they are evaluating the coordinate of P, Q, R and S respectively. Now I have to check either this one is square or rectangle or rhombus. Okay, so I am evaluating the length of the sides. Okay, since the coordinate is now known to us, so I am evaluating what will be the length of PQ by distance formula. As you can see, it will be root under 61 by 4. Similarly, this one and this one, the length of these four sides are equal to root under 61 by 4. That means only two options left. One option is either this PQRS can be square or it can be a rhombus. Why? Because four sides are equal in length. Now I have to check the diagonals are equal or not. Okay, what is the difference between rhombus and square? First of all, in square, every angle have to be 90 degree, right? Another difference is in square, the diagonal bisects each other uh, and the diagonals bisect each other and the length of the diagonals are also equal. Okay, for the square, the diagonal bisects each other and the length of the diagonal is also equal, but in rhombus the diagonal only bisect each other. Okay, then it is not necessary for a rhombus that the diagonal have to be equal. If the diagonals are equal, then that will become a square or a rectangle. Okay, now we will check what will be the length of the diagonal. So first of all, I am checking the length of PR diagonal. As you can see, PR diagonal is 6 unit. Similarly, if you check SQ diagonal, the length of SQ diagonal is 5 unit. Okay, that means the length of the diagonal is unequal. Okay, so since the length of the diagonal are unequal, so it will be a rhombus, not a square. Okay, if it is equal, if these two is equal, then it will be a square, but it is unequal, that's why this is a rhombus. Okay, so in this way you have to solve this question. So this is all from this exercise 7.4 and this is all for today. Thank you.